So we are discussing about the electrical logging and the DMPL3 instrument, which is used for both gamma, caliper, and also resistivity. So let us first see about the logging techniques. So when this borehole, we generally lower the probe, and that will give you the short normal, long normal, and lateral also. So if you want to find the diameter of this borehole, then we'll be using the caliper log also. And to find the properties like porosity, we'll be using the gamma probe. So let us start. Now in the well logging, we'll define the well logging as a continuous recording of the physical properties, and the main objective is to identify the formation thickness and identification of fractures and porosity, and also some boron correlation and the salinity of the formation mud, and also some properties of the rocks. So this borehole environment, generally we see like the type of fluid or the type of rock or the type of formation or the fractures what we have, we'll say that as a borehole environment. So when you drill the bore, generally drilling mud is circulated inside the borehole while drilling, and mud cake is formed on the walls of the borehole, and some of the mud will be pushed into the layers of the borehole, that we call it as a flush zone, and the whatever the material is inside like water or oil and gas or anything, that will be pushed back, and that will call as a zone of transition. So in this you'll have a mix of the mud which is coming from outside and also the material which is already inside like the oil and gas or groundwater. And the uninvaded zone is something where the drilling mud didn't even go inside, and whatever the material like oil and gas or water is still there without any disturbance. And we see here the thickness of the bed and also the borehole diameter. All these parameters we can find out using the borehole loggers. So we have a different kinds of logging. One is the self potential logging. The SP log or the self potential log, we use it for correlating the lithology, finding the porosity, permeability, and also the bed boundaries. In the electrical resistivity method, we generally pass current through the electrodes on the ground and also the electrode that is present in the probe. And based on that, we will be finding the potential difference. So first, let us see this initial setup. So we have the logging cables and the winches to move the cable up and down, and also a generator to provide the power and the recording system. So if you see, this is a probe. You have two electrodes on the surface and two electrodes attached to the probe. So the current electrode one is in the probe and the other electrode is on the top. The potential is on the top, the other potential is in the bottom. This is generally a Werner configuration. So we can see there are different spacing between the electrodes, 16 inches and 64 inches. These are the distances what we call as short normal and long normal. So we will discuss about the short normal, long normal later. And then coming to the factors that affect the resistivity logging, the pore geometry, and also the resistivity of the water, whether it is a saline water or fresh water or hard water, and then the porosity of the formation and lithology of the formation also, and also sometimes the degree of the cementation, and also the type of clay that is present in the rock. See, if you take areas like sandstone or a clay area, you'll have different values on the resistivity. So let us discuss about the gamma and caliper log application now. So this is the basic setup of DMPL3. This is a gamma cum resistivity caliper borehole logger. So if you see the components here, we can see there is a generator which is for the power supply, and the depth encoder which is used to find the depth, how much deep we are going, and these are the resistivity probes in which you'll get the resistance and self potential, short normal, long normal, and lateral. And the golden color probes are gamma and caliper probes. So in this you have radioactive material gamma, and the caliper probe for finding the diameter of the borehole, and then you have winches for connecting the instrument to the ground current and potential grounds, and this cable is to connect the borehole logger to the instrument, and this is a motor driven winch. So using this winch, you can control the speed of the lowering and lifting of the logger. And this control unit will be used for recording the data. And you have a speed control unit that can be used as a regulator to control the speed. So initially, we need to go for the winch and remove the connector. And this connector should be carefully removed by rotating the pin and then slowly lifting it up. Care should be taken while joining the connector to the probe, and after that you need to connect the probe exactly. The slit should sit on the 4-hole slit, and then you need to rotate this wheel, and it should make a sound so that the connection is strong. If this is not strong, then automatically there won't be any supply or any communication from the probe. So you should be very careful, and also this pin should be very carefully inserted or they will bend. So most of the people commit mistake here by connecting. So you should keep them on a flat surface and then connect like this, and both of them should sit exactly, and then you need to tighten the wheel, and after that you have a cap on the top, so you need to rotate the cap and then fix the joint properly. This particular area should be taped so that no water goes inside, and then you need to see like it is fixed here with the help of wrenches, and you should be very careful while rotating also, because too much tightening will spoil the threads, and too much loose will let the water go inside. So you should be careful while doing the connection. And after that, if you see, we have connected the probe to the cable winch, and this is how the total setup will be. So we have kept a depth encoder on the top of the borehole, and from this we need to insert the borehole logger. We are right now testing the caliper log, gamma caliper. So we are connecting it in this way. So this is the depth encoder which will give you the depth manually, and the same will be shown in the recording system also. So to connect that, we will be connecting the cable from the recording system to the depth encoder. So we have options here like the depth indicator. So in that we will be connecting it to the depth, and then we have generator which is used for powering the whole setup, and then to the winch, so that will be connected to the winch also. And we have C ground and P ground, those are connected to the electrodes on the ground. And then we have the front view of the recording system. So you have the speed control unit which you can control the speed up and down, so that you can understand how speed you wanted to move the logger down or up. And if you change the switch to up, then the logging will be done up logging, and down then the probe will be going down, and it is down logging. In general we do the up logging. And right now if you see the total setup of the recording system, we have the software connected in the laptop, and then we have the on and off switch, and we also have this resistivity and gamma on and current. So when you are going for the gamma caliper log, you need to switch it to the gamma or caliper. And when you are changing the probe to resistivity, you need to shift the switch to the resistivity. And once you press on gamma, then the gamma will be activated, and then you can proceed in the gamma caliper. You should not use this button during the resistivity logging, and you must control the current based on the area. of your investigation. So the application, when you see, we open the Gamma and Caliper application, and then when you see, you'll have from file Gamma and Caliper, and exit. So we go for the Gamma Caliper option, and this will enable both the Gamma and the Caliper. And this Gamma is only for going for the Gamma logging only. So we'll go for both the Gamma and Caliper. So once we click on the Gamma and Caliper, we'll see a window like this. In this, you have to enter any information like the way you are processing, or the location, and the latitude, longitude if you have, and the initial depth at what you are starting, and the COM port number to which the port is connected. And once you see this information, you see, click on the probe on or off, so that the probe will be on, and then you can see the readings here. So now the caliper is also on. Caliper on means the caliper log, the legs of the caliper will open, and then the logging will start. Caliper logging should be done only while up logging. That means while the probe is coming from the bottom to the top, then only you should use the caliper log. So now we'll see the data. So I have entered all the details, and then when I click on the probe on, I'm getting the probe on, and then the voltage, current, and the depth and the speed. So that shows that the probe is active, and then we'll go for a few status, in which you will see the voltage value, current value, depth value. This showing that the probe is active now, and then once you go to the graphs, you'll see the logging. So, and also when we go for the gamma option, we'll see the only gamma here, graph in the graph. And then when we go for the gamma and caliper option, we see both gamma and the caliper also. We'll see, like, once the caliper is on, it will show you that the arms are opening, so the processing has started. So you see the open arms, that means the arms are open, and they are slowly capturing the diameter of the borehole. So when the logging is started, you can see the readings are increasing with the depth. So the logging has started, and you can see the line starting from the gamma. Once you have this blue line, that means the gamma started activated, and the borehole diameter also started by the caliper. So you can see this is the depth at 3.2 meters, and the speed of the probe is 9.7 meters per minute, and the gamma value we have 125 count per second, and the present diameter is 11.3 inches here. As you keep on going, you can also see the, here in the graphs you can see the graph, and in the instrument data you can see the uh, readings. So as we keep on going, you can see the graph here. So the graph will be saved in the instrument during the survey. You can just close the probe off and caliper off, and then you can close the port and exit the program, so that the data will be saved. And once the data is saved, if you want to view the data, you can go for from file, and select the data, and then the data will open like this. And the same way you have a graph here. So this graph is little too close. So if you want to apply filter, you can click on the filter here, and then you can change the scale, uh, depth scale and all. So you will get a maximized image like this. See, you can see the separation when the scale is reduced. After this, you can enter the values of the depth and minimum and maximum depth, so that the scale is changing here. It is 5, 10, 15, 20, and here if you see 20, 40, 50, 90, 100 like this. So just to have a better resolution, we zoom in the depth by changing the values here. And once you have this range, then you can print this whole setup in a A4 sheet or a PDF file. And if you also want, you can give some color to the text. So you can maintain this as a layer by layer information also. So example, you can make this as a clay zone and give some coloring, and like you can give the range and you can explain what is that zone. So that will be applied to the graph. This is only just for the uh, representation, and then we'll see the different loggers probes for resistivity also. So the resistivity we have short normal, long normal, and SP. So these are the resistivity probes. The same way we'll connect the resistivity probes also, and this connection is simple. We'll just insert it properly and then make sure the threading is closed completely, and then we connect the current and the potential to the grounds from the instrument, these two winches. For gamma and caliper, there is no need of connecting the current or potential outputs to the ground. Once this is done, you'll put the probe above the depth encoder and let the winch go down. And this depth encoder, you can see the components here. So we'll start the probe, and then when you increase the speed, the probe will be going down. And in the application, you see well logger. In the well logger, you can see new logging, and then add the details like name, location, and all. And then you should choose whether you are doing the up log or the down log. Mostly, we will be doing the log. Defaults which will be in the log down log. You can check whether you are doing the up log or the down log, and then you give the name and click on OK. Once this is started, then you can see the readings in these columns. So you have the current here and initial depth and the depth and the speed, SP value, short normal, long normal, lateral. So once the logging has started by clicking here, then you will see the difference here, the current that is coming and the SP, the depth and the short normal, long normal readings and the graphs. So this is how we'll see the graph reading, and then you can click on the red button to stop. This is how you want to open the data. You can go for the IGS log and then open the data in the log, and then you can see the date, time, and the log and the log information and the graphs of the SP, the short normal, long normal, and lateral. If you want to disable anything, you can click here, and then the respective graph will be disabled, and you'll get the remaining graphs. So here I've got the SP and long normal. And if I want to give the color to the graph, I can add the color by choosing the SP color. So I'm giving a range for this one, and then I'm saving this as a PDF. So I can get the PDF like this. So this can be used for further processing of the data. And in the final, we have a mud resistivity also. Mud resistivity is used to find the resistivity of a drilling mud that is being used in the field while drilling. So we take a sample of mud and fill it in the barrel, and then we have a 12-volt battery that is connected, powering the mud resistivity and the system. So we open the application and then we add the details and then we click OK, and we'll see the current. And if we click on start, then the count will start. And when you see the values here, resistance is 3 and apparent resistivity is 3 here. So that is how we'll find out the mud resistivity. And we can also use the other version of well logging application in which you can open the data and see the resistivity log here. So this is a sample data where we have a regular pattern of logging data we have got, and we also had this caliper log, the resistivity log, and the SP log. So you can mix all of them and correlate. And as discussed earlier, you can give some coloring.